We started with scalar multiplication in the last video, and we now want to combine matrix addition with scalar multiplication and matrix subtraction with scalar multiplication. So what this means now is that the principles for matrix addition will be involved. Likewise, the principles of matrix subtraction will be involved. So D, let's begin with number 1. D is 6, 8, 2, 14 plus 3B, which is 2, 1, 0, 1. So the first thing we do, according to Bodman's, is to solve the one that has brackets or the one with scalar multiplication. So this will be 6, 8, 2, 14 plus 6, 3, 0, 3. Now the rule of matrix subtraction or addition involves that they must be of the same order. So this will be 2 by 2 and this is also 2 by 2. Therefore, if we say that we have D plus 3C, for instance, now D in itself is a 2 by 2 matrix. This 3C, C is a 1 by 3 matrix, and we can say that we will not have a possibility of solving a D plus 3C because this is 2 by 2 and this is 1 by 3. Now let's proceed. So now to solve this, now we are going to add the corresponding terms. So this will be 6 plus 6. I'll skip that process, and this will be 12, 8 plus 3, 11, 2 plus 0, 2, 14 plus 3, and that's 17. So we have our answer of D plus 3B. I believe you got it. Let's move on to the next. So we have D now minus 3B. Now it's simply the same thing that we have here, except that it's negative in a sense. Except that it is negative. So we have negative and we have negative. So we just perform the operation by subtracting each term. So this is 6 minus 6, 0, 8 minus 3, 5, 2 minus 0, 2, 14 minus 3, which is 11. So this is D minus 3B. Yes, there are so many operations on matrix multiplication, or scalar multiplication. So just as we have done the forward format of K multiplied by Aij is equals to Kij, we can also have the reverse format that says Kij is equal to Kij. So we can call this forward and we can call this backward. So in the backward form, we'll just look for common terms. So if we have, for instance, 10, 25, 40, 30, and let's say 35 and 45. Now we'll look for the common term there, and the common term for 10, 25, 40, 35, 45, and 30 is 5. So this is 5 as a scalar multiplication. So 5, so this will be 10 divided by 5, which will be 2, 5, 8, 7, 9, and 6. Therefore, when we multiply this in scalar multiplication, we would have this. Let's take one last example on scalar multiplication. So we are asked to evaluate for x if 5 4 3 7 3 minus 2 1 4 3 2, and this will result into wx and yz. So this is a combination of what we have done so far. This is scalar multiplication, likewise this is scalar multiplication, and this is matrix subtraction. So let's begin with the scalar multiplication. This will give us 20, 15, 35 and 15, because we're using 5 to multiply all the corresponding term, minus this will result into 2, 8, 6 and 4. Now we know that this is still equals to wx yz. Now we perform the scalar subtraction, and the scalar subtraction in this case will result into 20 minus 2, 18, 15 minus 8, 7, 35 minus 6, 29, 15 minus 4, 11. So which is equals to wx yz. Now with this done now, in the principle of equal roots, since the two matrices are equal, then the terms are equal. So we have w is equals to 18, x is equals to 7, y is equals to 29, and z is equals to 11. Now the question says we should evaluate for x, therefore x is equals to 7. So in concluding the scalar multiplication, we know that k aij is equals to k, where k is a scalar multiplier and aij is the element of the matrix.